Hello everybody, we are working in a problem called net present value. So it's called the net present value to this, or something called the NPV. What we're going to do is we're going to try to solve a problem for net present value. Now, if you'd like to see this in your textbook, it's on page 452, 453. And I am looking at the net NPV of the net present value of a particular project that we're thinking about doing. So the equation overall is called the NPV, and I'm going to so you can see this. It says NPV. It's equal to CO plus C1, and then there's a bracket, and it's PVF, and then it's K, and it's 1. So let me just explain this. So CO, 0, O means the start, 1 means the first year. And then you would do this if you're doing this multiple years. It would be C2, which mean the cash flow. C is cash flow over the second year. Okay, and then you have the PVF K2. Now what you have here is the K. Little k is interest, and then the period, or N. Sometimes this is also known as N. Corresponds to the year, so it's the first year and the second year. Now, the assumption is that you're going to have a problem where somebody is going to start a business and they are going to have initial outlay of cash. And so the initial outlay of cash to get your business started is always going to be in negative parentheses. So in the first year, say for instance you might put $10,000 down. This is your initial outlay of cash, and you put $10,000 down. Coming right out of your checking account. So then the first year, like a C1, you might make some money. So if you make money, and then it's a positive number. In year 2, if you make money, and I'm just writing some just numbers down, then if you make money, it becomes positive. So for instance, in this particular equation, if you put $10,000 down on a small business, and in year 1 you make 5, and in year 2 you make another 5, well, you hit the break even at the end of year 2. Well, we have the NPV, and we need to solve a problem. So let me put a problem up on the board or here on the screen for you to see. And what we're going to do is we are going to use the PVF table. So I'm bleeding through, so I got a little dots there. So let's start off, and we are going to use this company called Aiden's Lawn Care Company. Well, Aiden was going to go start a lawn care company, and he wants to buy a truck, and he wants to buy some mowers, and he needs to buy a plow because he's in New England. What they want to do is it's going to cost him an outlay of $12,000. This is the outlay of initial capital. So then in year 1, or C1, he is going to make $6,000 from his contracts. Then year 2, he'll make $3,000. Year 3, he'll make $4,000. Then in year 4, he is going to make it really big. He is going to start making $10,000. So let me just go back over this. Aiden has a $12,000 outlay to purchase a truck and some lawn equipment in order to start his company. And in the first year by his contracts, he's going to make $6,000. In the second year, he's going to make $3,000. The third year, $4,000. And the fourth year, $10,000. Well, the bank, because he's going to borrow this, is going to charge him 8% interest. So this interest is also known as the cost of capital. So he's got an 8% cost of capital. Well, what we need to do is we need to figure out what the NPV will be after 4 years. If you follow along on example 10.3, what we are going to do is we're going to see if this project should be undertaken. Now let's get back to our original equation. Let me show this to you. Here's our original equation. Our cost of capital, it goes C1 plus PVF K1 K2. So the way that you would set this up is we would go this way. We would say, let's pull this here. Okay, it's a CO. So the CO, so you can see this, the CO for Aiden's Lawn Care Company would be, say, NPV is equal to $12,000. Okay, it's a negative. plus C1. Now he made $6,000 first year, so it would be 6,000, and then it would be PVFK1 plus C2, which was 3,000, PVFK2 plus 4,000, because this is C3, PVFK3 plus 10,000 for PVFK4. Very simple. Now we need to figure out what the PVF is. So we know our cost of capital is 8%. This is cost of capital. And if you remember, we're going to go to the PVF table to find our numbers. So let me show you where that is. Let's open up the textbook. We are going to flip through. I am in Dr. Lash's textbook. We are looking at the what we call the PVF table. So let me just show this to you so you can see. It says PVF right there. And so we are going to look at 8%. So 8% is this particular number right here. So we are looking at these four numbers: the 0.9259, the 0.8573, the 0.7983, and the 0.7350. That's years, and you can see this years 1 through 4. So the way we set this up, let's just get back to this problem. It's a very simple calculation. So we would say 12,000, use this 12,000 plus 6,000 times, now the PVF would be 0.9259. Where we got that from was here in the table. There's an 8% mark. The period was 1, so for the first year it was 0.9259. So then the next would be 0.8573, so it would be plus 3,000, and then you multiply that out times 0.8573 plus 4,000, and then the next one, if you're looking on your own, would be 0.7938, and then the fourth one would be 10,000, and then it would be 0.7350. Basically what you're going to do is you're going to multiply the 6,000 times the 0.9259, the 3,000 times this, 0.8573 plus 4,000 times this number. And then if the NPV, let's go back to our rules in chapter 10 in the textbook. If you go back to the rules, if NPV is greater than 1, you would accept the project. If it is below 1, you would reject the project. So as we go back to in chapter 10, I'm just going to go get back to the question here. So what we're looking for is, here's the rules. If NPV is greater than 0, you accept it. If NPV is less than 0, you reject it. I'm sorry, I said 1, but it should be 0 according to the textbook rules. Okay. Every company is a little different, so your company may have something different than this. So that is how you figure out problem number 2 in our homework. You just do the exact same thing that I just did, and you'll be good to go. So this again was net present value.